Hi everyone. Now I'd like to talk about an example about constructing a confidence interval for a population mean. So here we have a weight loss program. So 40 of them use this program. And after 1 year, their mean weight loss was found to be 2.1 and the standard deviation of the weight loss is 4.8. So now we'd like to construct a 90% confidence interval for the mean weight loss for all such subjects. So 40 is just a sample. So here's the formula that we need to use. But from the questions, we already know a couple things. First, the sample size is 40. Once you have the sample size, you can calculate the degrees of freedom, which is 40 minus 1, so it's 39. And then the sample mean is given to be 2.1, and the sample standard deviation is given to be 4.8. And since we're constructing a 90% confidence interval, the confidence level is 1 minus alpha equals 90% or 0.9. Okay, so basically you can see the only thing left to find is the t-score. So the t-distribution is like a normal distribution where it is symmetrical in bell shape. So to find the t-score is very similar to the previous section. So first the confidence level is 0.9. So that's the area in the middle. So the two-tail area will be 0.05 each. And that can be calculated by 1 minus 0.9 divided by 2. Now let's find the t-score. So now let's see. Second vars and then choose INVT. Now I believe some of your graphing calculator probably do not have this INVT. If not, that's fine because after this I will show you how to find the same t-score using table A3. Okay, so similar to INV norm, we first input the cumulative probability from the left. So say I want to find the left-hand side t-score. So I put 0.05. Then the next thing I need to put is the degrees of freedom. So in this case it's 39. Okay, usually it takes a couple seconds to calculate it. Alright, so here's the t-score on the left-hand side, so negative 1.685 if I round it to 3 decimals. And equivalently, you can also find this number from table A3. Right, and like the normal distribution case, the other t-score will be the opposite of it. But now we can also find that one first. So second vars and then INVT. So now we need to input the cumulative area from the left up to the right-hand side t-score. Okay, so that will be the sum of 0.05 and 0.9, which is 0.95. Okay, comma, and then the degrees of freedom, 39. Hit enter, so here's your t-score. Alright, so now let me show you how to find these t-score on table A3. So first of all, we know that the area in each tail is 0.05. So you look at the column where it says area in one tail, it's 0.05. So if the area in one tail is 0.05, then two tail will just be the double of that, so it's 0.1. So you're still looking at the same column. Then after that, you look down on the table and look at the row where the degrees of freedom is 39. Then you see 1.685. Okay, so the structure of this table is different from table A2, where the first two rows are the probability, and the left-hand side column is the degrees of freedom. Moreover, the number in the body of table A3 are the t-score, specifically the positive t-scores. Okay, so that's how this table is structured. But we know a t-distribution is also bell-shaped symmetrical. So once you have the positive t-score, you can get the opposite one, right? Okay, so here's the t-score here. So after that, just plug in everything we have into the formula. Then simplified, you get mu it's greater than 0.8 and less than 3.4. Okay, that's it.